Hello everyone, I'm Sangeeta. Today I will talk on interfaces in Java. Interfaces. It is one of the most interesting topics in core Java, and it is very important topic also. So first let us have a look on the agenda for today's session. So we'll see what do we mean by an interface in Java. Then we will see why we require interfaces, why do they exist. Then we'll see what is their significance and all the benefits that we get through interfaces. So I'm considering right now that the audience is well versed with four major pillars of object-oriented programming, that is encapsulation, abstraction, inheritance, and polymorphism. Right? Again, we are very much aware about what is static polymorphism and what is dynamic polymorphism. Right? Now, before diving into interfaces, right, a quick revision will help on few points, right? Like the important benefits of inheritance, reusability of code, and dynamic polymorphism. Then another important point to note is multiple inheritance is not allowed in Java. A class can extend only from one class, right? So if I'm trying to write class A extends B comma C, that is not allowed. Right? If a class contains one or more abstract methods, then we have to declare that class as abstract. If you are not comfortable with those points, my advice would be to go and explore it more and then start with interfaces. Now, why interfaces? What is the need of interfaces in Java, right? So there are various reasons, and interface is a very, very important entity in Java. How we are going to see that? Clubbing together non-related classes under one roof. For that, we will use interface. Then achieving multiple inheritance. In the previous slide, we saw multiple inheritance is not allowed in Java. That means a class cannot extend from more than one class. But a class can implement more than one interface. But when we are making the statement, it is interfaces are there to achieve multiple inheritance. We should be very clear about 2 points. That is, we achieve dynamic polymorphism through interfaces, but there is no code reusability. So we'll come to this point. And the most important point about the interfaces that one should know is interfaces are there to achieve loose coupling. Now, what do we mean by loose coupling and how interfaces, through interfaces we can achieve loose coupling? We are going to see that. So we will cover all those points one by one. Interfaces are sometimes known as programming by contract. A class that implements an interface is bound to implement all the methods declared inside that interface. Now, in the day-to-day life, we come across certain entities. which are not related, but still they have something in common, right? And when we want to deal with that common thing, we will make use of interface. So to give you an example, to understand the first point, how interfaces help to club non-related classes under one roof, let us consider two entities. One entity is car, another entity is portable generator. Now these two entities are altogether different entities and they do not extend from same type. So car might be extending from a vehicle, while portable generator might extend from a generator class. So these are two different hierarchies. These two classes or entities are not related, right? But still they have something in common, right? And if we want to deal with that common thing among these two different entities, non-related entities, how do we achieve that? So what could be the common thing between these two non-related entities? Maybe both have the ability to refill. So now that common ability of refilling, now I want to deal with that refilling capability of both the entities. So how do I do that? So I should create a type refillable, maybe, right? But now that refillable, car should also be refillable and the generator should also be refillable. Should I create it as a class, refillable? If I am creating it as a class, the car which extends from vehicle cannot extend from another class, that is refillable. Same is the case with generator. And these two are different non-related entities. They should not extend from the same class, right? So here, non-related entities having something in common. Now that particular common ability or that type will create it as an interface. And now whoever has got that ability, whichever entity has that ability of refilling, will implement that interface refillable, right? What is the common behavior here? To refill, right? So we may have a method here. We may declare a method there inside the refillable interface, that is refill. Now, should I implement this refill method inside the refillable interface? No. Why? Because car will have its own implementation, how it should be refilled. Same goes with generator. Generator will have its own implementation for refilling. So, refill method inside the interface must be abstract. Whichever entity or class is implementing that particular interface will provide its own implementation for that particular method inside the interface. This is how the interface methods will be by default abstract, right? So this refill method will be abstract, declared inside the interface, right? Now the car will implement this interface refillable and has to provide the implementation for refill method, its own implementation. It will put its own refilling logic. Same applies to generator. Generator class will also implement the same interface Now it has to provide the implementation for refill method, and it will have its own logic for that. Right? So now these two non-related entities we are clubbing together under one roof, that is refillable. Now consider there are two different classes. One class is date, another class is employee. Now both the objects of date and employee are printable. So these two entities coming from different hierarchies which are non-related, but still they have something in common, and that is printability. Now in this case, we will create an interface printable, and let us do it quick hands-on. So as we discussed, we have a class date, right? It has DDMMYY and our standard class writing. Similarly, we have another class that is employee, and that employee class has ID and name, right? Now these two non-related classes have something in common, that is printability. So for that, let us create an interface printable. So we will create it as an interface. The name we are giving it as printable, and what method we are going to declare there, that is print. By default, the method is abstract inside an interface, right? Now our date class and employee class, both they want to implement the same interface, right? So let us quickly implement that. Now what is a must for this date class? It has to provide the implementation of print method, right? Otherwise, we have to declare that class as abstract. So what is the print implementation for this? We want to print DDMMYY. So this is the logic for print method inside the date class, right? Now similarly, for employee class also, we will implement this interface. And implement the print method to print ID and name. So now in our user class, if user want to deal with the printability of date and employee objects, so these objects, how you should create those objects? Now we will make use of printable interface reference. Now here P1 is the reference of printable, we can create the references of printable, but we cannot create the objects, right? Because interfaces do have only abstract methods. So similarly, we can create another printable reference, printable P2, which will point to a date object. Right? So now these two non-related classes, employee and date or entities, can be referred with a common reference, that is printable type. Right? So this is how clubbing together non-related classes under one roof, printable, that we have done. Right? Now let us go to the next point. What was the next point here for interfaces to achieve multiple inheritance? Achieve multiple inheritance through interfaces, but only it is limited to achieving dynamic polymorphism, and there is no code reusability. Why? We already saw that interfaces can contain only abstract methods. So there is no code. There is no method implementation. There is no code. So there cannot be any code reusability when we are using interfaces. But then what is the another advantage of inheritance? Achieving dynamic polymorphism. So that particular advantage we get through interfaces also, right? So how interfaces will help us to achieve this multiple inheritance or dynamic polymorphism? Let us go back to the code, right? Now consider we want to create multiple objects which are of type either date or employee. And our intention is to only invoke print method on each of these objects. So I want to create, suppose 5 employee objects and 7 date objects, right? And then invoke print method on each of these items. If interface or printable interface is not available, suppose interfaces are not there, then we have to create 2 different arrays, one for employee objects, another for date objects, and then invoke the method print, right? But now, because of this interface printable, can I create a single array of printable references to point to different types of objects like employee or date, right? So I cannot create the object of interface, but I can create a reference of interface. So I can also create an array of printable references, right? So let us call it P, yeah, equal to new printable. Right now I am creating an array of length 4 only. Please remember, though we are using new keyword here, we are not creating the object of printable. If I try to write like this, printable P3 equal to new printable, that will be a compile time error. We cannot instantiate an interface. Here we are instantiating an object, and that is its type is array. This syntax is for creating an array which will hold the printable references, right? Now we will just initialize it. So P of 0, say we are creating a date object. Then I want to create an employee object. Employee. We'll create 2 more objects. So now we have these 4 objects, right? 2 of which are of type employee and 2 of which are type date. So we have different objects, but we have created a single array of printable references. Now our intention is to only invoke print method on each of these objects. So let's take an enhanced for loop. Printable px. So every object of element of array p is taken into px. And then what next? Px.print. Let us run this. So if we see the output, p of 0 is a date object. So when px is p of 0, print method of date class is getting invoked. Then for p of 1, employee print method is getting invoked. Again, then date, then employee. So depending on the dynamic type, data type of the reference variable. What is the static type of p of px? It is always printable. What is the dynamic type of px? It is either date or employee. So depending on the dynamic type of px, that particular method in that class is getting invoked. So can we say that we are achieving dynamic polymorphism through this? So data type is decided at runtime, which method to get invoked, right? So this is dynamic polymorphism, and this is achieved because we are creating this printable interface. So we have seen interfaces help us to club together non-related classes under one roof, and interfaces help us to achieve multiple inheritance only restricted to dynamic polymorphism. There is no code reusability, right? Now the most important point and the important benefit of interfaces, that is loose coupling. We will cover that in next session. Thank you so much.